Мам, я забыл, как стримить. Мам! Всем привет. Всем привет. Привет, Кощей, привет, Айгудук. Hi, Garrett Kelly. Да, очень давно не стримил. Не помню, как это делается. Значит, на самом деле произошло очень много всяких событий, и часть из них очень плохие. Я даже не знаю, рассказывать или нет. Наверное, расскажу. У меня, в общем, близкий друг умер недели 3 назад, и до этого он пролежал в больнице больше месяца. Вот. К чему я это говорю? Это то, что, короче, клещевой энцефалит очень плохая штука, и все относятся так наплевательски. И, в общем, это так лучше не делать, да? Вот. Msoft, привет. Ладно, это был Public Service Announcement такой. В общем, переключаемся назад на рабочий режим. В общем, что я сегодня хочу рассказать вам. Мы недавно выпустили вот эту вот интрочку 4К. Как обычно, очень быстро сделанная, слишком быстро. Буквально собрано за последние сколько-то там часов перед пати. Капец, я совсем забыл, как стримить, как быть на камере. Так. Пара-папам. Короче, давайте рассказываю просто как есть. And another thing, like, welcome, hi everyone. Today's streaming will be in Russian. If you have any questions in English, please ask. I will switch to English for some things if you want to understand what's going on. But generally, my streams are mostly in Russian. And today's stream I will be explaining how this intro was made. Давайте начнем. Я ее вам покажу прямо из Тулу, как она есть, потом расскажу, как это сделано. Walter Pi, Russia. Hi, Walter Pi, Russia. I can still say some things in English, so please ping me, because the decision to make mostly Russian streams comes from my audience. Like, I see that most of my viewers are Russian speaking and some of them not English speaking at all. And I do have, like, English audience is smaller than Russian, but I was scratching my head about, like, how do I please both audiences. It's kind of hard to do. Have no idea how to solve it. Maybe I should hire someone, like, to live translate it or something. Anyway, can watch English streams. Макс Тукс, привет, я поздоровался, нет, я не помню. Okay, let's do this. I will stream mostly in English then, and sometimes switch to Russian if there is anything not really clear for Russian viewers. My voice always can decide, like, what language I will use this time. Maybe I should make just some clicking noises and please no one. Привет, Sirenius. Okay, so I will show you the intro in the tool, how it was made. Just a quick thing if you haven't seen it. Here it is. Ну, такая, в общем, штука. Привет, остров. Привет, Soft. I was showing you this from the tool, and let me show how it looks like from how it's actually made. So yeah, this is the tool. I can scroll it in any direction, and the tool that I use is my custom thing called Stameska. It's open source, not really documented. I've been writing it on parts of it on stream some months ago. Kostik, привет. Yeah, so basically it's just a path tracer with a heavy texture on the walls. So you can see that there's a room and there are walls, and there's the setup is as usual this live coding thing where I can just change anything on the fly. Yeah. So it's writing it with here. Yeah, this this tool, the first sources that were resulted being in this tool were written like about a year ago, but they were written for a 64K intro where like the intro and the tool was undistinguishable from each other. That was the same code base, and then I extracted a few things there to make a standalone tool. Гекарка, привет. Да, релиз был на Evoke. So yeah, this intro took like 3rd place at Evoke. I think it was like tied for 3rd place with another thing. Yeah, there's this. I tied for the 3rd place for this thing. It's kind of weird because like this intro was way better than anything else in the component for some live voting glitches. I believe it was wasn't voted for properly, and it ended up for 5th place. So if that wasn't the case, our thing would be tied for the 1st place. So yeah, it's not really strong. As always, whatever I do like a few hours before the deadline. So there's this scene which I made kind of early, and like there's a lot of scene going on. Still a few things I haven't seen for the music, and the engine, like I didn't have any time to like move camera properly, to have proper transitions for the 2D for the flat effects. Yeah, just me as always. So yeah, the basic idea here, as I said, is just a room with just a cubic room with 3 of the walls being kind of a display, and the scene is path traced. So we have kind of there's a lot of comments, like there a lot of iterations went through the making for the last few hours. And from the technical side, we have like the same shader is used to produce both the geometry to trace raised through the walls, and to make the 2D picture. The 2D picture is a separate texture for performance reasons, because it becomes super heavy to do these effects in real time when path tracing. So what I do is like there is a separate path to generate a texture. It like has this size. So yeah, this is if you haven't seen, it was on some of the previous streams half an hour ago, like we were making the 2 renderable live codable pipeline. It's declarative in nature, so I can say like, okay, I have a frame buffer that called like this, with this size. It has a few textures. Here I have only one texture with like 8-bit color, and it is a ping pong texture, so I will read and write to it. I ended up not using that. I was like, one of the iterations had some 2D feedback effects there. Unfortunately, I had to remove that because I didn't have time to finish effects before like polish the effects before the deadline. Okay, and then I have program. Is a trace shader. This is only single program, and then when I do like first I draw to the frame buffer with the same program, and yeah, draw full screen. Then I draw to screen with the same program, and like as there's just a single shader that draws to both the texture and the screen, I make the distinction by like looking at the resolution at which I'm drawing. Сталин и Ленин are alive. Привет. Я нет. Обычно я стараюсь вести стримы на русском, но сегодня народ в чате жаловался на то, что мы хотим по-английски, мы хотим понимать, что происходит, поэтому я переключился на английский. Если английский непонятен, я могу дублировать вещи на русском и опять быть в этой странной ситуации, когда я не понимаю, на каком языке мне следует говорить сейчас. Yeah, I got the first complaint that stream is in English, so I will be switching languages from time to time. Я не умею эльфийский, и японский я перестал тоже уметь. Я говорю краткое введение. Короче, вот есть такая интрочка, занимает 4 килобайта, заняла 3-е место на Evoke пару недель назад. Я рассказываю то, как она сделана. Это вот есть тула. В туле есть шейдер, который программируется на лету. То есть я могу на лету какие-то вещи менять. Я могу там менять размер комнаты, например. Ну, такое. И это паст-трейсинг, то есть с каждого пикселя летит много лучей, они отражаются по стене как попало, поэтому тут Global Illumination, всякие дела. И вот, краткое введение. Да, и здесь используется, то есть здесь сцена это просто комната, ну кубик какого-то размера, и на стенах, на 3 стенах из него сделаны, проецируется текстура, которая готовится тем же шейдером, но в отдельном пассе, отдельно рендерится. Содин, привет! Да. Я тоже по вам соскучился, мои сладкие. Я надеюсь, что я буду чаще стримить теперь. Okay, so as you can see, like, okay, the content, the idea is there, we have a texture, we have a scene, and there are some camera movements. So one of the things that I was trying to do with this intro and ended up not finishing before the deadline and I was making a separate thing for support for automation, like key value times key value, timed value thing, like timeline, whatever. Have no idea how it's called properly. Basically this thing. So we have some uniform and we specify which value it should have at which time. As you can see, like I made a lot of these things, a lot of values, experimented a lot with the scenes, all within like a few hours to do the intro. And I ended up completely not using that. I ended up rewriting all these, all the values here in actual shader, like 3 hours before the deadline or something. Like it was really tight in time. Yeah, I'm editing everything just in a text editor. There is no UI support. like it's just a shader I have. There's like some input support, so I can press spacebar to pause and pause. I can use arrow keys to fast forward and rewind. There are a few other things, like I use plus and minus to tweak the resolution. So if I'm working on something that's super heavy, I can lower the resolution for it to be most in real time, and I can, to see the end result, I can have resolution that is like full HD or something. As you can see, like it's still like 40 frames per second, but the video capture, like screen capture, is super slow for you, so I lower it a bit. Okay. Then there's a bunch of stuff, like there's lots of the code are for the timelining. So where should the camera be at particular time, and what should the effects be at particular time. О, боты подъехали. Okay, next thing here is pretty important, and I haven't showed it properly, unfortunately, is the fact that there is a depth of field effect. This is made properly. I should probably explain how I do it. So let me pick a scene that is more likely to show it. Yeah, you can see it here, like this is kind of blurred, this is kind of blurred, and this is in focus. So one of the effects here is like we can do this. I will show it on this scene. Lens FOV. So I can edit FOV, and I can do focus. Where should I? So yeah, I can change the focus distance. What? Why doesn't it work? Do I have some? Yeah, I rewrite it later. Yeah, okay. 0 wasn't a good idea. Oh, yeah. Yeah, as you can see, I can edit this, and also there's I removed the argument for that, but I can effectively change lens size and make lens like super huge for the scene, to make it like, okay, this is a smallish, we are looking at something really small. Что-то делает движок для UFL 2, выдал open source проект типа OpenLara не видел. Буду ли я доделывать до игры? Наверное, нет, не буду. Есть уже одна из идей, которая у меня была, и я это скажу, потому что я не знаю, буду ли я это делать или нет. Идей очень много. Идей очень много. Это то, что есть open-source движок для первой халвы. И был, который написал какой-то русский чувак, по-моему, в одну каску. Можно его найти, взять и попробовать прикрутить к нему RTX, сделать рейтрейсовый движок для первой халвы. Да, Ксэш, по-моему, да, его звали. Вот. Капупукча. Securitron, да. Ну, видимо, боты пролезают каким-то образом. Красная книжка, это по C, по-моему. Так, okay, so Okay, what I was, yeah, one of the things was the depth of field effect, and another thing was like this is a properly, there are refractions, which kind of not really well seen, and the refractions are actually wavelength dependent. They are not really physically correct in any way, but they still look like there's some color thing going on. I will try to tweak it to show you, I believe somewhere here, make it more pronounced. Yeah, as you can see, like there's some chromatic aberration going on. And how it's made is actually like super dumb and super brute force. Basically, so as this is a path tracer, it has a lots of samples per pixel. Like there are 32 samples per pixel, and for each sample, it randomly choose the current wavelength, and basically each sample carries just a single wavelength. As you can see, like there are some really cool effects here, like how it's called, like caustics or something like this. So we can actually try to make it more pronounced by regularly by making 2D effects something like make some bright thing here. Я пропускаю чат сообщения. Хочу сделать движок для первой паки с лучами. Круто, дерзай. RTX заказал, еще не приехало. Мод, привет. Как через шейдеры использовать RT-ядра? Или там специальные шейдеры со структурами оптимизации? Короче, там очень простое API по типу... задаешь. Я был на презентахе, я съездил на SIGGRAPH в этом году, наконец-то. И там была лекция про то, как это все прогать. Там простое очень API, что-то типа надо задать способ, каким сцена описывается через баундинг-боксы, и автоматически в железным образом карта будет строить BVH. А дальше задается, соответственно, функция пересечения, тоже там типа как компьют-шейдеры, функция, как она отрисовывает, и функция типа как порождение лучей или что-то такое. Я плохо помню, я перечитаю это, но оно какое-то, оно тематически очень простое. И это что, это DirectX 12 или Vulkan? Вот. Привет, Александр. Да, на Twitch тоже транслирую. Вопрос, по какому тегу можно найти информацию про преобразование плоскости экрана в 3D плоскости его последующей? Я не понял вопрос. Но это как бы projection, просто проекция, наверное. В OpenGL расширения RTX, насколько я помню, не было. По крайней мере, оно мне не попадалось. Okay, I was telling about RTX. So we were discussing with chat what to do, and one of the questions was like, will I continue my Half-Life 2 rendering thing? And I said that probably not, but what I wanted to do is pick up some custom 3D engine that was made to play Half-Life 1 games and make it RTX, make it like with ray tracing or path tracing. Sometime in the future, and we were talking about how RTX API is made, and I was talking like it's kind of simple. There are like just 3, I believe, shaders that you specify, which are like compute-like, and everything else is automatic. And I have an RTX card on the way to start doing something. It will be maybe a few weeks later. Что делать, если человека привлекает больше математика, чем программирование? Куда податься-то с математикой? Не, ну есть люди, можно заниматься математикой как наукой, а можно, не знаю, ну, заниматься чем интересно, это прикольно. Как бы математика в программировании тоже часто нужна. Можно искать, где математика нужна. Вот, можно попробовать посмотреть на какой-нибудь Яндекс, там, не знаю, у них есть школа обработки данных или что-то, как это называется. Вот. Такое всякое. Yeah, you can see that there are some weird things here. I can make more samples and it will be super slow. Because like it's all random, there's no important sampling or anything. It's just whenever a ray hits the surface, it will reflect in random direction. Голос погромче, сейчас попробую. Я когда тестировал, был клиппинг. Надеюсь, сейчас нормально. Так, математика, да, про математику сказал. Есть применение математики в программировании, где, да, можно ходить в халве уже ретрейсинг, это выберешь гаусса, трейсишь лучики прямо. Хорошо, да. Голос сделал, машинное обучение с питона, для математики. Да, нормально. Почему тихо сегодня? Не знаю. Не знаю, я тестировал, чтобы было нормально. Павел, привет. Понял. View XSRB. Я не знаю, что это. Это ссылка какая-то, наверное, что ли была. Шейдер. Шейдер той. Окей, сейчас посмотрю. В алгоритмах сжатия можно, там, да, там много всего можно делать в программировании с математикой. Я не сильно знаком с этой областью, не подскажу дальше. Физику со временем планирую. Okay, we have kind of derailed into... sorry, but I will look at it, and this is the last thing I will have to reply. So I believe, I have no idea how it's actually made here, but no idea. I could understand, like, from reading this how it's made, but basic idea how to if you want to basically you're looking for a ray plane intersection. There are multiple ways to specify a plane, and usually what you do is you have a normal and offset, so like you have 4 numbers, and with that it's really simple, like it's easy to figure out the exact equation you need to do for your ray. And after that you can kind of calculate where on the plane you are and limit it if you want. Basically, the ray triangle intersections works in a similar way. It's kind of optimized because if you go through the equations, you can see that okay, you don't need a few of intermediate steps, if I recall correctly. Yeah. Я просто очень натренирован, не надо пугаться, это просто много часов практики. Делайте так же, будете такие же. Это классно. Что математика бодрит, математика интересная, это очень классно. Но это надо просто делать хобби-проекты с математикой, которые хочется, и смотреть по сторонам, смотреть, кто ищет. Я говорю, Яндекс искал математиков сильных с уклоном в программирование в свое время. Не знаю, как сейчас, скорее всего, то же самое. Ну и вообще много кто там, то же самое машинное обучение, там много машинное обучение, там много всех, да. Окей, продолжаем. I believe I explained how I kind of skipped an explanation how path tracer actually works because I explained it many times. I will just go through it really quickly. So basically, for each pixel on a screen, we have a cast array, and I do for the depth of field thing. What I do is, let me try to start drawing this. Wow. I'm not used to that new thing. Whatever. No, what happened? How do I? Why? It's super slow. So basically, what I do logically, there's like a logical sensors, which has like logical pixels, and then there I have like logical lens. And I have no idea how it works. Like I completely forgot my physics from like 7th grade or something. And then I have imaginary plane from which I need to pick a pixel. So what I do is I actually start pixels from across the lens. And the idea it looks kind of like this. So for each pixel you have rays that go through this and this. I can draw. Like from a point on the sensor you have rays going through the entire lens, and they will end up at some point here, like at some zero size dot on this plane. And how I do this calculation is I actually start my rays throughout the lens, so I have a lot of samples here that go through a lot of samples, lot of rays, all of them for the same pixel, and I make him trace him the way so they hit a single point on this plane, and like I can control these. This is a focus, depth of field, something. Remember how it was called? Yeah, this is lens focus. Yeah, this is lens focus variable, and then I can control lens size, and then I can control what else? There's like depth of field, not the depth of field. Field of view. How do I control field of view? A field of view is basically this distance, like how far away can this go. So it can be limited to this, or it can be like this. And as I have multiple samples, I just go through all of these points here, all of the trays here, and just sum them together. And this automatically gets depth of field effect, because like if your object somewhere here, for example, the rays will diverge from this point, and you will have a really blurred image, because like they will sample this object at many places. And the same thing goes for some object here, like you will have a lot of samples for this thing. Yeah. focal disk. Yeah, there's a lot of terms that I don't really need. I need them, but I don't really understand them. This is like I came up with this picture with some rudimentary knowledge I had. X привет. Я пропустил очень много чата, сорян. Пока только в DS, в YouTube, я в YouTube. Сейчас в сфере. Другим что могу, сейчас сделаю. Нормали погнуть. Про плоскости и луч. Короче, надо смотреть. Я не могу отдельно про это как-нибудь сделать. А самый простой случай, кстати, это пересечение плоскости с axis align. Плоскость, которая лежит на какой-то из осей, это то, что я сделаю здесь. Здесь у меня плоскости, они пересекаются с осями, но здесь это гипероптимизировано, то есть тут вот такая вот функция, которая пересекает сразу все плоскости, сразу все. Вот. То есть вот в одну строчку я пересекаю со всем кубом разом, и дальше просто типа выбираю, какая из них плоскость ближайшая, и все. Depth of field здесь абсолютно корректные, они не по-разному, это, видимо, просто из-за недостаточного количества сэмплов, кажется. Павел Суков, пока, спасибо. Не знаю почему, но вообще на русском очень мало контента, да. Quake, что-то было, но я плохо помню, надо будет посмотреть. That is a big shader. Yeah, this is a 4K intro. Like the final executable size is 4 kilobytes. And I haven't told you about this part. And well, do you have time? Yeah, I can. I think I have half an hour. Сейчас в данный момент фрилансер, это хобби. Конкретно эта штука это хобби абсолютно. Я делаю это иногда вечерами и там за несколько часов до дедлайна, до конкурса. Okay, so let's continue what I was. I was telling how path tracer works. So depth of field part is just tightly integrated in the path tracer, so there's a lot of samples. I can do this because I have a lot of samples, and then for each sample I cast a ray from the lens position, as I told here. For like imaginary lens position, it's not like there's a real lens in the scene, although there are these refracted ball. And I trace it through this magic function, this magic equation through all the balls. How it works is like I have assigned sign for the ray direction vector, which is normalized, and then I get this variable that is like why sign is important, because I want to hit far plane and the plane in front of me and a plane behind me, as I have to pick which one of them depending on the like ray direction. So this took a few minutes of writing the equation down on paper and to figure out, okay, I can do this, I can really do this in a single line, and I ended up with a vector that is kind of for each component of this vector is a distance of ray travel to hit that particular plane. And if I comment some of these things, you can see that so this hits only Z plane, this hits Y planes, and this hits X plane. This is super weird, but yeah, it works. And the M thing here, so I pick the nearest, the shortest ray traveled, and this is how I get like minimum of all planes, so we're inside the cube. And then the M variable is just a material number, which is gets picked up later to get the actual pixel color and other properties. Learn OpenGL прикрыли, что? Не, вроде есть. I didn't see it. Yeah, there's a chat somewhere here. You should see. Yeah. Не учите, дети, OpenGL вреден для здоровья, да? Okay, and then there's a special code for ray sphere intersection, and I do special thing to figure out like how where I'm inside or outside. Not here. I have this variable to figure out that I'm inside or outside the sphere actually. So I will flip it. And it also has a material here, and this is not really important, but I will go through it in overview fashion. So for each material that we have, we figure out which material we have, and we have like our rate hit position in the world, we have our normal, we have what else, like distance traveled, material. Yeah, and from that we can figure out what color we will have. And so this material less than 3 is material for all these walls, and I have to calculate texture coordinates to read from the texture, and that's just it. ME is forgot the word. It's emissive color, so basically this will add to the this will actually create a light source in the scene. If I remove that, it will be dark. This is the only light source in the scene. So this texture here is the only light that's coming through this into the scene. There is no like point light, no nothing. It's pure pass tracing from unknown for random rays to pick to randomly hit whatever lit pixels on these walls. This is how you get those nice global illumination effects. Then what we have like materials more than 4 are other things. M4 is floor, so they have like MA is albedo, it's how much light you pick up from you reflect back. So like these low values make this scene kind of dark. R is roughness, so I can make it. Why? What happened? Okay. So if I make it 0, it doesn't change anything. So this line is completely not needed really. The floor is there's some modulation on the floor going on. Nobi said that it's super cheap, and I can kind of agree. Modulation there is just to make those. Let me focus on it better. Lens focus. 5 or something, and maybe lens size. Yeah, you can see like there are some mirrory parts. There are some modulation through coordinate distortions going on. Super cheap. Like I agree with Nobi. This is embarrassing. But this is what I came up with like really quickly, and yeah, I wanted to do a proper height map, normal generation, probably using the same intermediate texture as I used there. I think I had some experiment here to read these values from texture. It was it was faster than doing this modulation here, because like noise is super expensive to do, and there are a lot of noises here. Okay, and then I have ceiling, which is kind of mirror. It can be less mirrory. Yeah. It can be like this. Just MR is roughness, just tweaking the roughness. And then I just add the emissive color, modulate with current ray color impact factor. I'm not sure how it should be properly called, but basically, like, whenever rays go deeper, less and less a color from that ray can end up an actual pixel color. Then if it became super dark, we just exit early, so we don't waste any computation on that particular ray sample. And then there's this thing where I refract if it is if we do refractions. Yeah, so the refractions are only for this ball here. And then if we are not doing refractions, we do regular reflection of the ray, random ray reflections based on roughness. So like if roughness is 0, we do perfect reflections. If roughness is something more than that, we mix the ray with some random vector. This is how it's not physically correct in any way, but it's super cheap to do. Like easy, conceptually very easy to do, and this is how my past tracer works. And then there's this factor to be able to cast rays only in normal direction, so we don't actually try to cast ray through the geometry. And that's pretty much it. Like there's some color grading things, some like improved brightness, so without this is super dark. And this is the shader part of the intro. Music was made by Keen, and I have no idea how to talk about that. Okay, I think I missed a lot of chat. Let me go through the chat. Не ставьте Linux на микроволновке. Почему? Да. First 2019. Yeah, I didn't participate in 64K intro that took first place in assembly this year. Function was really fun to do. Thank you. Игорь, привет. Я не брился месяц, наверное. Мне медленно растет волосня. Да, я рассказывал много грустных новостей. Меня не было отчасти из-за них, отчасти там из-за всяких командировок. Зенитур, привет. Эпичные книги по компьютер-графике на русском языке. На русском языке не знаю хороших книг по компьютерной графике, к сожалению. Увы. Большинство книг на английском, и не все из них хорошие. Okay, this is cool effect right here. Kind of blue-ish. Will I be able to catch it again? Nah. Anyway, there's another part of this intro that I haven't told you about. It's the actual native code, and this is I'm really proud of, and no one sees that. It's because it's an assembly that I have handwritten like during like hour or two, and it worked from the first time I compiled it. It worked, which is like really impossible to do when you are writing assembly. And when you are writing like really complex, it's not like super complex, but it's still not really straightforward. Yeah, there's it still was picked up through from other parts. Like I obviously didn't write all of these down by hand. I didn't do all these by hand. I had some of these things. These I had before, but I had to like structure all of these things together. And how it works, there's a lot of boilerplate code. So so in order for us to fit in within 4 kilobytes, we need to have native code really compact and really do only what's really necessary. People in 4K category usually write C code or even C++ sometimes. I really love to write assembly because it's not super hard to do, and it is actually it ends up being 100 or 200 bytes smaller, which is a good thing because you can have more stuff in music or in shader. And sorry, how we do everything here is there's some like a fan call thing. So we have an entry point where we start the intro, and there's this helper macro fn call, which lets me write function calls in a really simpler than doing like all the pushes by hand. So the macro just pushes all the arguments on a stack in the right order, and that's pretty much it. Yeah, there's this some nice macro magic that I wrote a few months. I wrote it, I believe, last year, and I don't remember how it worked, but it should be really simple. So yeah, there's this fn call thing. Just get rid of a cursor, create window, get device descriptor, prepare OpenGL context, generate a texture, properly set all the things that we need with the texture, generate from buffer because we need to write to this texture, like yeah, prepare the frame buffer. As you can see, like I do this thing where I don't preload these functions beforehand. I just call them, we just get these function pointers at the place where I call these functions, and this lets me because of this, I completely remove the part that loads these functions beforehand, and it's kind of faster. I think I have to have a short break, sorry about that. Sorry about that. Okay. Капитан, привет, где пропадал? Я был в затяжных командировках, и в общем всякие плохие новости. Best image was simple deferred shader on OpenGL 4.0. Okay, still cool. I haven't worked with OpenGL later than 2.0. This is I will have to do this. I will have to do research and maybe do something really cool. Okay, so yeah, this in place function loading tends to be a bit smaller than doing function preloading. So this is what I do all the time. So yeah, then there's usual like, okay, let's create a thread that will render music. And then there's, yeah, create shader program. There's only one program, then play music, and then get current time from music position to have proper sync. And then I do this weird thing where I push all the function arguments on the stack before I actually call the functions. Like I do push these in bulk, and I also wanted to do this here, but ended up not doing that because like it still fits in the 4 kilobytes, so I didn't need to do anything super fancy. And then there's like a set uniform for time, then there's set uniform for resolution. Yeah, not for time. I think this uniform is for both resolution and time. Yeah, I think it, yeah. And then there's, we have to have a specifically a set of texture binding location. Yeah, and then we paint to the frame buffer, and then we paint to the screen. And yeah, this painting was a macro. Okay. So we actually end up having a lot of this code, but it's kind of the same, so it packs really well. And then we call these functions for which we have prepared the arguments on stack beforehand. Yeah, this is kind of important so Windows doesn't think that the program died. What's shader? Yeah. На вулкане в 4К не уложится. Там слишком много, там 1000 строк, чтобы нарисовать треугольник. Let's do this up. Oh. Yeah, this is basically the same thing here, right? На ассемблере. Ну, кстати, отличный челлендж. Давайте по программированию вулкана на Asm. Очень круто. Okay, so this is this. Are there any other important details here? Yeah, one of the things is that I have sections for each piece of data that needs to be contiguous, and that's this let's sprinkler, which I and all of others 4K coders use for compressing the intro. And maybe I can show you actually how it's compressed. I'm so good at drawing. Let me draw you a cat. I will draw you a cat right now. This is how I draw a cat. I'm an artist. Okay, crinkler. GL15, I believe, right? And other thing that I can do from here, I can actually build a Windows release from my Linux machine. I just have to specify like GL15 fast. I will do the fast version. What? Why? Why? Oh, okay, so there's this problem where latest version of Crinkler won't work on Linux. They crash for some reason, so I have to download the older version. No. Okay, and then I can make fast. I kind of was explaining. Crinkler has crashed. Why? It was working. So I won't be able to show you cool things from like Crinkler reports. Why? Why would that happen? It did work. I'm not lying to you, it did work. Okay, let's try with the most recent Crinkler maybe. Maybe it will work. No, it crashes. This is sad. I won't be able to show you the if I do slow, will it also crash? Yeah, it did work. I have no idea what happened, why it broke. Maybe I have some weird libraries there. I should rewrite them with something that worked better. Yeah, let's pick these libraries. But those are the same. Sorry guys, this is pure Linux experience right now. Not sure why it's like that. It did work. It did work really well. Can I look at the dumps? Maybe I can like wine CFG something. Windows 7. Okay, let's do Windows 10. We don't do anything really fancy here. Okay. Fine. Ah, it still crashes. Okay, no Crinkler report for you guys. Sorry. Okay then. I think this was pretty much it. I'm not sure what I could tell you if there is anything else. You can ask questions. Oh, I completely missed talking about the 2D effects actually. The thing here is that there was a lot of, I did a lot of iterations. I started working on 2D effects. Like, actually, this intro as a like skeleton for this intro, it started a few months ago. And I was experimenting with some of the things, but it didn't materialize. Okay, this is a product that we should release until like 10 hours before the deadline. So yeah, there was a lot of iterations with various 2D effects, and I think most of them are broken now, so I can't actually show anything beyond what I have here. But yeah, the usual thing, how it's made is there's a lot of things. Why it didn't affect anything? Why didn't this affect any? This is something that happens at the very end. So there's a lot of noises, a lot of like steps, so we have to and yeah, it's kind of heavily mixed with the timelining, so it's hard to break this down into individual components. But maybe I can do something. For this I need to open the same thing but side by side, because there's a lot of weird stuff. Let me actually like delete everything. Yeah, I can do this, which I ended up not using at all. Remove all the unnecessary crap that is on the as you can see, there are lots of experiments. Lots of experiments. Will this work? This won't work. Okay, yeah, there's a lot of timelining. It's hard to break down to individual components, as I said, but basically I can try to do something like, okay, return C here. Doesn't do anything. If I do it here, yeah, there's it mixes the previous scenes. Okay, we can start from the top of this thing. So let's have a runtime light version of this. These will do some really cool modulations. This will do a coordinate modulation, basically, some noise one. So at each point, vector is shifted by some random amount. It can be seen on this thing, for example. If I have 0, it will have these nice lines. If I have something more than that, they will be heavily distorted. This is how final scene works. Not the final of the scene, before the final. Okay, there's this modulation, and then there's noise thing, so we can look at some really nice noise. And this noise is used in many ways. And what, like, making this intro was a lot like this. I just tweak some things to figure out what's going on. Yeah, and usually it doesn't really work like it. Oh yeah, this is supposed to be fractionalized. And then I can do things like this, so... And yeah, this is basically the scene that we had. What this does is it has a length, so it gets bigger and bigger to the as when you go far from the center, and then you have. This stream is still working. I don't see any activity. Okay, I really should finish my stream really soon. We're like, good. Nice to hear. Okay. What if you do this? How it will look like? Okay, this is some modulation for some later scene. Yeah, this basically destroys the randomness in here, the noisiness. So yeah, probably there is not there isn't any particularly good insight in what those 2D effects are, except one of the things is I have this Voronoi field, and this is really cool. And this is the last thing I will show you. So there's a Voronoi pattern, and I can do a lot of really interesting things with it. Like I can make it like this, I can make it other way around. I can modulate that with, yeah, there's, okay, there's this ring thing also, how it looks like. Yeah, there's just something like this going on. Then phase, what is phase? Okay, phase is weird. I'm not sure what's going on with the phase. So we have a Voronoi, and then I can multiply it with the ring, and what I will get is this weird pattern. I can also do this. Oh, yeah. Yeah, basically there's a special effect there that modulates makes heavy use of this modulation. Somewhere this part. Yeah, this part is just basically Voronoi modulation with this rings thing. And yeah, this is where I, a few hours before the deadline, and I was really tired. I just ended up throwing a bunch of random effects there, and that was it. That's the intro. So on this sad note, I think I have to finish my current stream. If you have any questions, you have like 1 minute to ask them. If you don't have any question, then thanks for watching and see you next time, which will be probably in a week. Снова привет. По таймингу. По таймингу. С той попыткой в Oculus на малинке, что... пока ничего. Пока не... В общем, не до этого было, я не смотрел в ту сторону. Да, да, но есть запись, можно посмотреть в записи. И, да, я думаю, у меня будет возможность стримить более-менее регулярно, поэтому приходите еще. Anyway, thanks guys and girls for watching this, and I will see you really soon. Веб-страницу с планетой буду делать. Не знаю когда. Окей, bye, пока.